Welcome to all. This is S. Mohan, Assistant Professor, Department of Mathematics in JJ College of Arts and Science, Autonomous, Pudukottai. Today we discuss about the topic is Introduction to Graphs. This topic is belong to the subject graph theory and this for third BSc Mathematics. First, we have to know the graph. Graph is a generalization of the simple concept of a set of dots, links, edges, or arcs. Here, the definition is a graph. G consists set of vertices denoted by V or by V of G and set of edges E or E of G. Mathematically, we can represent a graph G VE. Means what is a graph is the combination of the vertices and edges where E, that is the line joining the two vertices, that is or the edge. Example here, if we have suppose the vertices are V and vertices are 1, 2, 3, 4 and 5 and edges are 1, 2, 1, 3, 2, 3, 2, 4, 3, 4. So how can we represent our graph? First we construct your graph. First we draw the vertices. We have 5 vertices. 1, 2, 3, 4 and 5. Now draw edges are 1, 2, 1, 3, 2, 3, 2, 4 and 3, 4. So this is our the graph. Now if we have any graph, what is the order and size of the graph? So the number of vertices in a graph G is called its order and the number of edges is its size, and we can denote it by V and its size E, the number of vertices and the number of edges. Example here, if we have the type of graph, so you can tell me order of the graph. So find order of the graph, we have to check the vertices. Here, how many vertices here? A, B, C, D and E. Total 5 vertices. So, the order of G is 5. Now, what is the size of the graph? What is the size? Size is the number of edges. So, how many edges here? 1, 2, 3, 4, 5 and 6. So, total 6 edges here. So, the size of G is 6. Next one is adjacent vertices. Two vertices Vi and Vj are said to be adjacent if there exists an edge Vij in the graph G. Example, this is the graph. We have 1, 2, 3, 4 and 5. So 5 vertices. Here the vertices 1 and 2 are adjacent. Similarly, the vertices 1 and 3 are adjacent. Now, next one is directed edge. Ordered pair of vertices represent as UV directed from vertex U to V. Suppose we have the two vertices here U and V, and the edges join the two vertices, and here we have the direction U to V in which have the direction. This is the directed edge. So now undirected edge. Unordered pair of vertices represent as UV disregards any sense of direction and treats both ends vertices interchangeably. Means we have suppose two vertices U and V and join the two vertices here. Here no direction. This is the undirected edge. Next one, loop. What is the loop? A loop is an edge whose endpoints are equal, that is, an edge joining a vertex to itself is called a loop. Represent as U to U. Start from the one vertex and again come to the same vertex. So it form a loop. Suppose we have vertex U and edges come from this, go from this. This is make a loop. So it is called loop. Now multiple edges. What are the multiple edges? Two or more edges joining the same pair of vertices. These are also called parallel edges. Suppose we have the two vertices U and V, one edges U to V and another one edges V to U. Here we have two edges between two vertices. So these are called the multiple edges or parallel edges. Now kinds of graph. So first one is simple graph. A graph G that has no self loop or parallel edges is called a simple graph. Example, we have any graph G and the vertices are U, V, W and edges are UV, VW, UW. So we construct the graph three vertices U, V, W and edges are UV, VW, UW. So this is type of graph is simple graph. Here we have no self loop or parallel edges there. This is called the simple graph. Next one is multigraph. What is the multigraph? A graph G is known as a multigraph if it contains parallel edges. Example, we have any graph G and vertices are U, V, W and edges are E1, E2, E3. So this is called multigraph because you can see that vertices U and V have two edges. So we have parallel edges there. So this graph is called multigraph. Now next one is a pseudograph. What is the pseudograph? A graph G is known as a pseudograph if we allow both parallel edges and loops. Example, suppose we have the vertices U, V, W and the edges E1, E2, E3, E4 and our graph is like that. So here three vertices U, V, W and the edges are we have parallel edges and W vertex we have the loop here. This is called the pseudograph. Next one is directed graph. What is the directed graph? A graph G, set of vertices V and set of edges E or ordered pair of elements of V means we have edges or direction. Example, suppose we have the vertices U, V, W and edges are UV, VW, WV. But here we have the direction. This is called the directed graph. Next one is directed multigraph. What is the directed multigraph? Here G consists of set of vertices V, set of edges E and a function f from E to UV. The edges E1 and E2 are multiple edge. If f of E1 equal to f of E2. Example, suppose we have the vertices U, V, W and the edges E1, E2, E3, E4. Here this graph directed multigraph. We have the loops are there and multiple edges are there. This is the directed multigraph. Briefly, we can say that see the table. So type of the graphs. First one, simple graph, undirected edges. Multiple edges are allowed? No. Loops allowed? No. Next one, multigraph, undirected edges. Multi edges allowed? Yes. Loops allowed? No. Next one, pseudograph, undirected edges. Multiple edges allowed? Yes. Loops allowed? Yes. Next one is directed graph. So directed edges. Multiple edges allowed? No. Loops allowed? Yes. Directed multigraph. So directed edges. Multiple edges allowed? Yes. Loops allowed? Yes. I hope you all understood and would have learned the topic I am very happy to share this content with you. Thank you for the spend your invaluable time with me. Thank you.